Fine. So, okay. Now tell me, is network engineer need to learn OSI model or not today? If someone is going to learn today OSI model, and network engineer who is going to become network engineer, how it will be beneficial for them? If you are going to, let's say, master it, where it will help you, or network engineer don't need to learn it, the OSI model?
They need to learn it, sir.
Why? Where is the implementation? What you will do with OSI model in the network?
To segregate the issues
How?
layer by layer.
Layer by layer.
To know where is the problem exactly.
Okay, if I will give you some troubleshooting issues, can you tell me this issue belongs to which layer?
Yes, ask.
Yes.
Yeah.
Yes.
I'm telling you some troubleshooting scenario. The production, let's say, the application is not working. Issue is customers are complaining that application is not working. Which layer issue it is according to OSI model?
Application layer. Application layer, sir.
Application layer. What others? At least 5 people should speak.
It depends on the application. What's application?
That user interface is not working.
We are trying to troubleshoot the issue, right? But just we are assuming that is the application working fine or not, right? So this issue comes at which layer? Application, right? Layer
Yes,
7. And when I'm saying, let's say, DNS is not working, DNS is not working,
Application.
again application. If I'm saying, let's say, TCP connection is not established,
Transport layer, sir.
transportation.
when I'm saying issue is related to port number, I think port number is not behaving well on the server or router, any device.
Same transport layer.
Transport layer, sir.
Transport.
When I'm saying IP is not reachable,
Network layer.
if IP,
Network
IP there
layer.
is
I
IP
think
reachability, not able to ping, let's say,
Network layer.
network layer.
network layer.
Okay. And if switch port is not working, switch port, switch port is not
Data
working,
link layer, sir. Data
means
link layer.
Transport.
not transport, switch port. Switch port means layer 2 port.
Data link.
Data link layer.
And when I'm saying cable is not working properly, or let's say the connector is not working properly, like your audio
Physical.
Physical layer.
Physical layer.
physical layer. Let's talk about the designing for an example. If I will talk about the network designing, whenever you are going to design the network, first you will think about VLAN and trunking. At which layer it works?
Data link
Layer
layer.
2.
First of all, you are designing the layer 2, right? So again, in the designing, you are going through layer. First, you will think about your VLANs, trunking, then you will think about the IP addressing, routing. At which layer?
3.
Then you will think
3.
about the
Network.
firewall rules. Firewall works at which layer?
7.
Layer
7.
3.
See, most
Network
of the
layer.
firewall works at
Transport
all
layer,
layer,
sir.
but
Network.
Network layer.
main
Transport layer.
policy of firewall works at layer 4, right?
Yeah.
Many times you have seen this, right? On the basis of port number, we are controlling the traffic on firewall. So firewall is actually layer 2 policy. It's work at layer 4, but firewall can definitely works from layer 1 to layer 7 on all layer. But when we are designing the network, first we are thinking about the VLAN, then about the IP addressing, how we'll perform the routing, then about the firewall, then we'll talk about the SSL certification and those all things, like for the security. At which layer? SSL? SSL works at SSL and TLS for the security.
Transport.
Not transport, not transport, not transport.
Application.
Second layer.
Not application, not application.
Third layer. Third.
It's presentation.
Present.
SSL is going to be session.
Presentation.
Presentation layer.
Presentation.
Presentation layer, sir.
Presentation layer is responsible for encryption, decryption. Don't forget, huh? Right?
Mhm.
Encryption,
Okay.
decryption, compression, decompression.
Correct.
SSL is what? For the encryption only. And then we'll talk
Protocol
about
comes
our
under.
application, about DNS, where we are going to run the
Prabhu sir, one
HTTP
question.
or
Is there any
1 minute.
protocol works under
I'm
that
coming on.
presentation was
I'm coming on that. Coming on that. Coming on. What I'm saying, we can identify the issue belongs to which layer. Here definitely OSI model will help you while designing the network. Every time we design network from lower layer to upper layer, VLAN, then IP addressing, routing, then the firewall rules, then the presentation layer works, then about the application. Even in the security, if I will talk about the SDN, modern networking, software defined networking, there you are going to learn about underlay, then overlay, then application aware routing. That is SDN, right? Underlay works at layer 3, overlay layer 3, 4, and application aware routing layer 7. Everything in the network is working on OSI layers only. OSI is the main backbone of networking. Yes, whether you like it or you don't like it, if you want to become a network engineer, you have to learn it. Without OSI, network is nothing, right? And how many layers are there?
7.
7 layers.
At each layer we have a specific task, right? We have a specific, when we type www dot, let's say, google.com, what happened, guys? Can anyone tell me what happened when we type www.google.com in the browser? Based on OSI model, application presentation session, like that. When we type
From
www
the
I
dot,
think
DNS,
DNS
will
lookup.
change the IP. Yeah.
first DNS lookup.
Yes.
Here, first when we type
HTTP.
www.google.com,
Sir.
my machine have to generate some kind of traffic, na, at least.
Yes,
What
Sir,
will generate?
it
will
has
use
to
the
establish a
application layer, right?
connection.
Mm-hmm.
Sir,
Who will
it has
generate
to
that
establish a
that
connection.
data? No, connection is you know will come later. First,
I mean,
at your
when we will
machine,
type www, I mean, it is kind of providing us the user interface. So definitely, application layer comes into the picture when we will type www.
please speak loudly, brother. Your voice is very low, I think.
I'm saying, Praful, when we type www anything, right?
Mm-hmm.
Then the application layer comes into the picture because it's providing us the user interface because we are using
So for
some kind
what
of browser
application layer is responsible? For what?
to provide us the interface, right? To
User
on which
interface.
we can perform tasks. Yes,
Okay. Then
And then it will be then session will be created. It means it will generate the traffic station.
no. After application, then I mean we have typed www let's say google.com. Then it generate. I mean it will. We can say that it will generate some data. Then data will be forwarded to the presentation layer. On the presentation layer, encryption,
who will
decryption,
generate
or
the
some.
data?
It will use the protocol, right? That is the HTTP protocol.
Very good. HTTP or HTTPS. So when you type www.google.com, your machine is going to call to application layer protocol, right? So
Yep,
what you need to learn here, that protocol, HTTP or HTTPS, two protocols
yes,
to access web page,
correct.
right? Okay, now
Yeah.
data is at your machine, your data, actual data. What is that? That is request, some kind of code, information, program to initiate the connection with Google, right? You can say HTTPS request, HTTPS or HTTPS
Request.
or HTTP or HTTPS request. That is just a program. Now that same protocol, HTTP protocol, will hand over it to lower layer. Then, brother,
Then
then Then what presentation layer will do?
It will encrypt and as per the request, if
Encryption.
it's at HTTPS, then it will be encrypted. And if
How?
it's
With the help of protocol again.
yes, sir.
Encryption. See, accessing web page is what? Service. Encryption is what? Service. And to access the service, to use this service, we are using protocols at each layer. For every task, we have what? Protocol. As a network engineer, you just need to learn that protocol. That's nothing else. Right? So at if presentation layer is responsible for encryption, is that their service, definitely they will be using some kind of protocol,
Protocols.
TLS or SS.
Yes.
Yeah.
Okay, then it will encrypt. After that,
Session will be created.
then it will hand over to lower layer, session layer. Session layer will create the session. How? What will be the information in
Three-way
session?
handshake or
No,
Authentication.
three-way handshake really at session layer?
No,
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 that's
three-way
at the transport. I'm sorry.
I mean, it will
Authenticate, sir.
generate the connections like using the well-known protocol for the destination website. We are using HTTP or HTTPS. They have their protocol number, maybe 80.
Protocol number will
And
be added by transport layer, brother. Don't forget.
Port number.
Yeah,
I
port
think
number.
yeah, port number.
Port number will be added by
Port number or
transport
a
layer.
socket number, I think.
Your data
This
is generated at application layer, then it goes to session layer through presentation layer. We know these three layer. At session layer is simply going to create a session that from this browser with the help of some kind of sequencing, from this particular browser I have sent the request to the Google server, so that when reply will come, it can send that reply to the same tab, same browser. These three upper
Yeah.
layers are called software layer, right? So we are software engineers work.
Yes.
And after that, your data will reach to transport layer. Now tell me what transport layer will do. What is the function of transport layer?
TCP and UDP
It
works on the
is
transport
going
layer.
First
to-
of all, guys, keep in mind one thing, very important thing.
End-to-end connection.
End-to-end connection, reliability, unreliability, sequencing, acknowledgement, those all are fine. But the most important thing which you always need to keep in mind is the transport layer broke the data into segment.
Chunks.
Broken the data into segment. Application layer don't have any limitation. Application layer can generate any size of data. There is no any limitation, right? You can try to send 100 GB of file through WhatsApp, right? But when your application will access it, it will deny. It will ask you to compress the file. Transport layer can receive any size of data. And here transport layer will divide that into a smaller part. Why it will divide? You have to understand about MTU, maximum transfer unit. Maximum transfer unit is nothing but the capability of an interface to forward maximum size of data, right? If I'm saying MTU is 1500 byte, that means interface can send data whose size is up to 1500 byte, not more than that. If device need to send, let's say 2000 byte of data from that interface where MTU is 1500, router have to divide it because their maximum transfer unit is just 1500. It cannot send 2000 byte of data. Transport layer is responsible for this, and this particular thing is called flow control. Many time interviewer will ask you this question in interview, that can you explain flow control at transport layer? Flow control means now if the sender machine have broken the data, has divided the data, one big data into a smaller part, how receiver machine is going to rearrange it in the same sequence, right? It also help. Let's suppose you are accessing Google server from your mobile. Google server is a server, right? Their interface capability can be different from your mobile. Mobile is a small device, right? For an example, your mobile interface can process 10 Mbps data, means 10 MB per second. But the server, Google server can send 100 GB of data per second. So if you are downloading something, it might be possible that Google server will send data at the rate of 100 GB per second, and your mobile can receive only 10 MB per second. See the gap. What will happen? Here flow control is required. Someone is needed who can control this flow, otherwise there will be data loss at your mobile. Flow control means transporter can tell to server, hey brother, my capability is just 10 Mbps, slow down your speed. And if server is downloading from something from the mobile, server can tell to your mobile phone, hey bro, I can process 100 MB per second, you can send me fast, you can increase the speed. Like this is called flow control. What it is flow control. At which layer? At transport layer, which is the high top OSI model, sir and madam.
So window sizing is different than this.
Window sizing, we'll see what is window size, right? Window size is used to
So
reduce
it's
the number of acknowledgement,
okay.
right? We'll see that.
So does that TCP and UDP comes under the play then?
UDP,
Or
see, UDP works different from the
yeah,
TCP, right? Both protocols are designed for different purposes. If you need fast communication like video conference, you have different transport layer service.
but it will use the same IPv4 stack or IPv6
IP is
stack,
a
right?
network layer information. What
No.
TCP
To
will
send
do?
the data, sir. To send the data, right? It will use the same IPv4 header or something like that. And I'm just talking about end-to-end flow.
That is function of network layer. If there is IPv4, IPv4 protocol will work. If it is IPv6 based, IPv6 will. That is network layer. Forget about the lower layer now. At transport layer,
Okay.
the first function is dividing large size of data into a smaller part. Benefit is flow control.
So whether that is TCP or UDP,
TCP.
TCP only, right?
TCP only. For the UDP, then what will do? Can UDP divide large size of data into a smaller part of data?
No.
Yes. Yes. Yes,
Yes.
it does, but it does not acknowledge.
No, I
UDP
mean no.
does not perform segmentation. This particular thing is called segmentation means dividing large size of data into a smaller part of data. At transport layer, we call data to segment. Segment means maybe the small part of data plus transport layer header, and transport layer header can be TCP or UDP. Two protocols are there at transport layer. Sometimes we don't need to divide the data, routers can divide it. It is not required in the UDP, right? See, the protocol which works at UDP will work better at network layer. There is no any benefit of reliability and the acknowledgement. There is only one thing, that is fast communication. UDP is very basic, very easy, even you can ignore it, but TCP is very important for you. Most of the communication are TCP based. If you know the TCP, you can understand UDP very easily. Even you don't need to learn. The function of transport layer, what I am saying, not function of TCP. Even this is the function of TCP, but keep in mind like this, that at each layer, you know what is the function. The function of transport layer is first function dividing large size of data into a smaller part and then adding the headers. Which header? TCP header or UDP header. Both header will carry what? Source MAC, destination MAC with some more information.
Yeah.
With some more information. The main information is source port, destination port. Your data will get their identity at transport layer only. Application layer, when HTTP protocol has generated the request message, right? That data cannot go anywhere. They don't have any kind of address. This is the first address which we have attached with my data, that this data is looking for 443 port number or 80 port number, and then it will hand over to lower layer, network layer.
So once it comes at transport layer, the UDP traffic, it will then select the ports, right?
It will not select the port. Your operating system knows that if it is HTTP request message, then I need to use TCP protocol. If it is DNS request message, then I need to use UDP packet, UDP protocol. That your operating system is already designed based on OSI model. What I told you in first class, we come up with OSI model to make communication between different vendor devices. All the vendor are designing their operating system based on OSI model. That is the understanding of our operating system. Our operating system knows this. That okay, if application layer is generating HTTP request, I will use TCP protocol. If it is using if an UDP based protocol is coming or request coming, I will use UDP protocol. It will add the UDP header. Similarly, at network layer, what is the function of network layer? And guys, you guys were telling some more function. Now tell me, what are the other function of transport layer? Other, you guys were saying reliability and reliability. What is the meaning of reliability and unreliability?
Reliability means that it ensures the end user receives the data in the correct order without any errors.
I mean, every packet which is sent from the user to the end user, it is getting acknowledgement by the end user. So that's how the reliable communication will be there between the user and the other side, the end user.
Error checking as well, right?
Error checking, error kinds. Okay. And end-to-end
Sequencing.
communication, sequencing, three-way handshake. Those are the function. We'll discuss that, the three-way handshake, how it's work, everything. After that, that is fine. For transport layer, it is sufficient for now.
Just one question. So every time we see in the ISP network, right, or any other enterprise network where we see people are using transport, they are using this transport, that transport. What does that mean?
That is the link,
Is that
physical
MPLS?
cable for you. That is between two sides. We have one cable, right,
So that
to
transport is
connect.
different.
That is the same thing. That is the same transport. Right here between two sides, like a branch 1 and branch 2, the distance is used. That's why I am using internet. Both sides I have internet connectivity, and through which I have created the VPN. So internet is going to be considered as transport here. That is different
That is different, right? This
from
is
the,
not the
yes,
same.
yes. Right now we are in transport layer.
Yeah, yeah, yeah.
OSI model, what is OSI model? Definition, never forget. OSI model tells how two devices are going to send and receive traffic. This is all about data before forwarding from the link. All the layers will perform some kind of task, like your see task of application layer is generating traffic, HTTP request message. Orientation layer is responsible for compression, encryption. Session layer is responsible for creating the session. Transport layer is responsible to add the port number. Network layer
For host-to-host communication.
responsible to add the IP address, either IPv4 or IPv6. Data link layer responsible to add the MAC address. Then physical layer responsible to convert your data into bits or signal, whatever, depending on media. This is OSM model, and till here guys we have already discussed everything. Now let's start with some example now. See, I tell you honestly guys, at application layer you need to learn HTTP protocol, HTTPS protocol, You need to learn DHCP protocol. You need to learn DNS protocol. You need to learn FTP protocol. You need to learn TFTP protocol. And you need to learn Telnet protocol. You need to learn SSH protocol. Then
SCP,
SMTP,
SCP,
SMTP,
SCP, you can get idea about those protocols. Fine. SNMP, syslog,
BGP.
So why
BGP.
not SCP?
Huh?
Why not SCP?
SCP as well. I told you, you can learn it.
No, it's similarly it works as TFTP and SCP is the same, right?
No, you are going to use every day SNMP. Even SNMP is old. Nowadays we are using the modern tools to network monitoring. HTTP, these are the protocols of your syllabus that you need to perform lab. You don't need to perform any lab of SFP. SFP lab is when someone is going to install the EVNG, they will be using SFP protocol. Any other protocol important for network engineer? Then
OSPF.
OSPF is not application layer protocol.
Oh yeah, but BGP is application layer, right? Yeah.
Already mentioned the BGP.
SMTP.
SMTP. Etc. Application at transport layer, TCP and
UDP.
UDP. At network layer,
ICMP.
IPv4, which you have
IPv6.
already which you have already learned. IPv6, ICMP,
IC.
then OSPF, EIGRP, then okay, etc. At data link layer, ARPA, ARP,
STP,
physical, Ethernet, and wireless in the OSM module. For the practical, for the lab, is there anyone who don't have GNS3 and packet tracer? Installing the
I don't
software
have it
is
currently.
very simple. You can open any browser and just type packet tracer download. Cisco packet tracer download. Download and install it in your laptop. Like you install any software, you can install it very easily. It's easy. Similarly for the GNS3, by the way, for the GNS3, I had here one video. GNS3 setup. In the description of this video, you will get all the file, GNS file and router images. Right, GNS3 is only for routing. For the switching, we'll set up EVNG. Right now, for an example, I am going to use packet tracer for the practical. Like this only, you need to test these all protocol, whatever protocol here I have mentioned in OSI model. And If you will not practice, if you will not check, it will be difficult for you to understand the advanced concepts, right? Networking is 80% practice and 20% learning.
Sir, are you going to guide us through the labs? How it's going to be?
What lab?
No, the labs you are saying that we have to practice. That you will be giving us exercises to practice, and because for me personally,
You
I
will be
don't.
configuring the same lab which I am configuring in the class.
Okay. Because for me personally, I have never used Bucket Tracer, so I don't know the tools, how to use it, and so
Okay,
on.
so see, when you will open the packet tracer, you will get this interface. Are you able to see right now?
Yep.
This is my interface. Right, so when you will open your packet tracer in your laptop, you will also land on this page. Right, in the left bottom you can see devices are there. Are you able to see first device? These are the devices type. This is networking devices, then end devices. End devices means your PC, server, printer,
Yeah.
IP phone, right? Tablet, TV, smartphone. Networking devices means router, switch, hub, wireless devices, and firewall in the networking devices. And here we have the cable. The fourth one is the cable. Right, so right now you don't know about the cable, so always select the automatic cable. First one is automatic, choose connection type. It will not ask you for connection type, like which type of cable you need. If you are connecting router and switch, it will sense automatically whatever cable is required, it will use that automatically. So for an example, I need to connect two routers. I will drag and draw router. And which router you will drag and draw? For now, 2811 series router, or this one. For you, 2811 is best router for now to practice, or you can also use 1941 series router, right? So like this I can drag and draw two routers. I can rename it. I can say R1, R2, and now I need to connect them. So I will click on cable. I will select the first type, the automatic, chosen cable, and then I'm going to right click over here on the device. Right click on both sides. You can see automatically it has connected. Got it, Resmi?
Yes, sir.
How I am
And sir,
doing?
can you repeat? Can you repeat the routers we need to select? Which reference?
Sorry?
You said that we need to select a particular router. You said the reference
2811.
number.
2811.
Okay.
For now, this is the old router, right? Very stable in packet tracer. Almost all the commands are available here on the router, which you are going to use in the production in today's network. Right, then I need one server for an example, so I will click on end devices, and then again I will drag and draw one server here. Let's say this is my HTTP server. So how I will make this server HTTP? I will click on the server, I will go to services, and in the services here you can see HTTP services there. By default it's on or off?
On.
Both HTTP and HTTPS both are on.
On.
And here even you can see the website coding. If you want to edit, you can edit. Welcome to Cisco Packet Tracer. You can make it PM networking. If you know the HTML coding, you can design the website over here. Right, so this server is behaving like a HTTP server, means Google server. Here I can create the domain, same domain, google.com. Save. Then again I can connect my server to router. Very simple. Somewhere I have PC. This PC need to, let's say, access the server. So here you have to configure now IP addresses and those all things. How will configure the IP? If you don't know, don't worry, you will learn it. Simple. Here we are going to use, let's say, subnet 12 dot between router 1 and router 2. I will always use 12.1.1.0/24 between router 1 and router 2. Between router 2 and 3, 23. First number is router 1, then router 2, means it became 12, R1 and R2, and then 1.1.1.0/24. Hardly you can make it 30 30/30. Like this, you should also use the IP method. Here I can use 20.1.1.0/24 one LAN submit, and this side I can use 10.1.1.0/24. Can anyone tell me how many broadcast domain are there? How many broadcast domain are there?
3.
3.
So you can see 3 subnets are there, right? 10, 20 and 12. They all should be reachable with each other. We have to configure routing as well. For now, let me configure the IP, and we'll talk about the basic configuration, initial configuration of router. G0/1 interface, G0/1 no shutdown, and IP address 10.1.1.1 255.255.255.0 interface G0/0. Again I am saying no shutdown, and IP address 12.1.1.1 255.255.255.0. Just I have configured the IP address on router number 1. I can also I have to also configure routing, so 20.1.1.0 255.255.255.0 and G0/0 and 12.1.1.2. What happened? IP route 20.0 255.255.255.0 G0/0. Okay. 12.1.1.2. R1 configuration done. Similarly, I can perform configuration of I2. Interface, let me do one thing. It will be better if I will put the command in notepad, so that if someone don't know the basic configuration, they can use that configuration. Every day what I will do, I will first write down the command in notepad and I will share that with you. See, I am configuring R2. So the first command is enable, then config T, and you will learn the meaning of this command. For now, just use it. Then interface G0/0 no shutdown. By default, interface of router is down. IP address 12.1.1.2 255.255.255.0 exit. Then again interface. Now I am going to configure another interface. Interface G0/1 again no shutdown, and IP address 20.1.1.1 255.255.255.0 exit, and then one route IP route 10.1.1.0 255.255.255.0 and 12.1.1.1. This is my configuration of R2. Simply I will copy this command, and you should also configure routers like this only. Don't paste the command on router directly. First type all the commands in the production. You will configure like this only. You will have all the commands in your notepad. First you are going to check, verify multiple times, because by mistaken if you are going to down any interface, just think, if you will down any interface by mistaken, what will happen? The site can goes down. See, all the commands are accepted. Now I need to configure one IP address on this HTTP server. Let's say IP address over here is 20.1.1.10 and one IP address on this PC 10.1.1.10. Go to server, go to desktop, then IP configuration, and here you can configure the IP address 20.1.1.10. Subnet mask 255.255.255.0. Here gateway is required. In the packet flow you will learn the gateway as well. Done. Now I need to configure one IP on this PC, again desktop, PC, and 10.1.1.10. Subnet mask 255.255.255.0 default gateway 10.1.1.1. Right now I have not configured the DNS server IP address. Even you can set up the DHCP or DNS. Now if I am going to type the IP address of this server in the browser, I will get access of website, yes or no? Yes, from the PC. If you are going to check the connectivity, that reachability is there or not between PC and server. Ping 20.1.1.10. This ping is a utility which is used to check connectivity between two devices, that connectivity is there or not. If I will get reply message from the server, that means there is reachability. See, request timeout. I'm getting the error message. Means there is some issue, but now you can
No
see.
connection.
Now you can see 2 packet got reply. First 2 packet was got dropped because of ARP. For the first packet it was solving ARP, right? You will understand that process as well, which is happening behind the scene in the packet flow. Why first two packet got dropped, we'll discuss that. Now you can see all the I am getting reply message for all the packet. I had sent it how many packet? Sent 4 and received how many packet? 4.
4.
So that's why loss is
0.
0%, right? Lost 0, so 0% loss. Many times you will be using these all commands to troubleshoot the issues, to troubleshoot the packet loss, slowness, right? Here this is packet is it is not giving the exact output, but you will get timer information as well, that how much time it is taking to come, how much time it takes to come reach reply here on your PC. Like you can see for this request message, it has taken 1 millisecond. 1 millisecond for each ICMP packet. Now in the browser, if I am going to type the IP address, which is 20.1.1.10. Is it the URL? No, this is not the URL.
No.
Now tell me the protocol, which protocol you want to use. If you will not define the protocol, it will use HTTP, you can see by default. And it got the access of application. It's saying welcome to PM network. The same website. But remembering the IP address is tough, right? As compared to domain name. It will be difficult. How many of you know the public IP address of your Google server? Your public IP address, Ivan? No one. Right? But whatever things are on the cloud or on the internet are accessible through public IP address. But remembering the public IP address number is difficult. That's why we save number in the mobile with name. Remembering name is easy. Right? So we come up with a protocol called DNS. Who is responsible to solve this issue? Right? You will type domain name here. I can say www.pmnet.com or google.com, www.google.com. I will not get access of any page, right? But here DNS server comes in picture. Now you need to set up DNS in your network, which will be responsible to resolve domain name into
IP addresses.
Yes. So what I will do, I will take one more server here and I will name it what? DNS.
DNS.
This is my DNS server. What is happening? DNS IP address. For an example, the IP address of DNS server is 20.1.1.11 for an example. And let me connect it. And better to connect one switch here in between. I am going to take one switch as well, otherwise I need lots of port on, router. And which switch you will use? 2960 switch. In the packet tracer, 2960 switch. You will use this switch for your lab as well. And now I'm going to place this switch here, and I will connect all the servers to the switch. On the switch we have lots of ports, and we know how switch works, the function of switch: address learning and address forwarding. You know this. Now I'm going to enable DNS service on the DNS server. Go to DNS, go to services first, and then click on DNS. By default DNS service is enable or disable?
Disable.
So let me enable it, and I need to create one entry here, right? I am creating the database where domain name is, let's say, www. What you want? What domain name you want to define to 20.1.1.10 to your HTTP server?
PM.
Any domain.
PM networking.
PMNet. So pmnet.com for an example, right? And what is the IP address of pmnet.com? 20.1.1.10, right?
Then. Yeah.
Save it. First add and then save. Add. You can see like this you are going to create entry for your all application, all websites, all domain name on the DNS server. Now if your employee is going to type www.pmnet.com in the browser, www.pmnet.com in the browser, he should get access of website, but it is not able to access. Why? Because your machine don't know who is the DNS server. Am I right? Even you have set up the DNS, but your machine don't know where is the DNS, to whom I need to ask for the IP address of pmnet.com, isn't it? Yes. PC don't know
Yeah.
from whom I need to ask for IP address. Then that means, Praphul, on the PC we just don't need to configure, just we need to configure IP address only, or we need to configure multiple things? You need to configure IP address, submit mask, default gateway, DNS server IP address, sometime WC IP address, sometime SNMP IP address, right? So DHCP is a protocol who is responsible to provide these services. DHCP is not only responsible to provide the IP address. DHCP is responsible to perform the initial configuration of devices. You can see the configuration of your Windows operating system or Linux operating system or Mac operating system, any operating system. Similarly, either you can define the IP addresses manually, then you have to configure everything. What is the IP address of DNS? In future, if you are going to change the DNS server, you have to change the DNS server IP address on thousands and lakhs of PCs. Is it practical, guys? No, never.
Yeah.
We need one more server here, right? DNS server. Sorry, DHCP server.
DHCP.
Who will be responsible to provide IP address to the client machine? And because we don't have single client, we can have multiple clients here. Like this PC, we can have lots of other PCs as well. Here I have one switch, and they all need these all information. So if human is going to define, guys, IP address one by one, if any human is going to define IP address one by one, there is chance of error as well, right?
Yes.
IP address, submit mask, default gateway, DNS server, WLC. So might be possible that you can repeat the IP address, you can configure the wrong default gateway IP address, and it can create the issue in network. So better to have one DNS server. I'm going to add one DNS server this side here. Sorry, I'm saying DNS, DHCP.
DHCP.
This is my DHCP server, who will be responsible to provide IP. Now you can ask, Praphul, why you have added DHCP over here, why not here, and how these client will get IP address from the DHCP server? It belongs to different network. It is possible. I will place all the server in server room only, right? All the server will be in server room, clients will be in the building floors, everywhere. Doesn't matter. Some client can be connected with wired, some client can be connected with wireless, someone is working from the home, everything you will learn. So I am keeping all my server here, this side, and on the employees this side. And DHCP server IP address is, let's say, 20.1.1.12. These are the business need. Now I need to configure IP address on the DHCP server and the DHCP service here. Let me do this. Their IP address is 20.1.1.12 and submit mask 255.255.255.0 and gateway IP address 20.1.1.1. DNS server IP address 20.1.1.11. IP address is done. Now go to services and go to DHCP service, where it is here. By default DHCP service is enable or disable.
Disable.
So enable it. Define the name of your pool, DHCP pool. By default pool name is server pool. What should be the gateway? Default gateway IP address. See, I am configuring DHCP service for these clients. Here this submit is in 10.1.1.0/24 and the IP address on router LAN interface, R1 LAN interface is 10.1. That will be the gateway, 10.1.1.1. DNS server IP address 20.1.1.11. Starting IP address 10.1.1. Let's say 11 or 10. Subnet mask, this one, maximum number of IP, let's say 200, and save it. What happened? Invalid start IP address. Dot is not required. Save it. Done. DNS server is also set up in my network now. Now I can try to get IP from this PC. This PC cannot get IP here because of broadcast domain, right? Later you will learn more about the DHCP protocol. What is happening over here? DHCP works on broadcast DORA process. If client need IP address, client will generate the discover message, and discover message is going to be broadcast. Because if client don't have IP address, they don't know anything about DHCP server. Where is the DHCP server? So it will broadcast one message that, hey, if there is someone DHCP, please give me one IP address, like that. And you know, router divide the broadcast domain. This is different broadcast domain and this one is different broadcast domain, right? So message of this broadcast domain cannot travel in this domain. So that's why here I have to tell to router 1 that, bro, whenever you will receive DHCP discover broadcast message, just send it to DHCP server interface G0/1 and IP helper address. What is the IP address of DHCP server? 20.1.1.12. That's it. And now this client machine can get IP address from the DHCP server. Right now you have configured it manually, that's why you can see DNS server IP is not there. Now I'm going to click on DHCP and let me see this machine is able to get IP from DHCP or not. Not getting IP from the DHCP. Let me try again. Now you can see got the correct IP address, everything. Yes, DNS server is there now. Now your machine know what is the DNS server IP address. So now if I am going to type www.pmnet.com in the browser, www.pmnet.com in the browser, I will get access of website. What happened? Not getting. Let me see. Domain name should be same, www.pmnet.com. See on your machine which message it is? DNS message, right? This DNS message is looking for what? See here, this DNS message looking for what? This DNS request message is looking for the IP address of www.pmnet.com. What is IP address? This message is called DNS query message. See? Are you able to see? DNS query.
Yeah.
After that, see the UDP header. This is not UDP. Here it is. Source port, destination port. Are you able to see?
Yes.
At which layer? Transport layer. This DNS message at which layer? At application layer.
Application name.
Why we are not able to see presentation and session layer? This is TCP IP model, not OSI model. What it is?
TCP/IP.
TCP IP model. In TCP IP model, we have application, then transport, then network, then
Yes.
data link, and physical. So here we are able to see all the layers. Application layer, transport layer, then network layer, and
Data link.
data link layer. Right. So in the actual DNS request message, there is information of domain name. It will forward to whom? It is forwarding to 20.1.1.1 DNS server, right? Not HTTP server. This is DNS query for DNS server to ask what is the IP address of pmnet.com. It will forward to switch, it will forward to router, router will forward to R2, R2 will forward it to DNS server. No. Here is the issue. What happened? Now we need to troubleshoot. There is issue, some issue. Let's troubleshoot it. So IPR 20.11, 20.11, 20.11 is not there, right?
No.
Ping 20.1.11. Even ping is not working. There is issue with reachability. Let me check DNS server. IP is not configured here, guys. 20.1.1.11, 255.255.255.0. Default gateway 20.1.1 and DNS server IP not required here. And go and refresh your page now. Now you can see I'm getting the page, right? With domain name www.google.com.
pmnet.com.
If I want to change the domain name, where I will change? I want this application which is hosted over here on this server should be accessible from Praphul.com. Where I need to change?
Other
On the
DNS.
DNS only, right? If I want, there is one another server. Right? I want these users should not access the application which is running on this server. I want the same application running over here as well. This client machine should access service from this server. Where I need to change the IP address? Here,
From DHCP.
DNS.
DNS. Okay.
pmnet.com. Earlier IP was 20.10. Now 20. Let's say 20. Others client can also get IP 10.11. And 10.12. So you also need to design and configure these protocols. In OSI model, we will learn it. And guys, if your network size is small, you don't need to purchase a dedicated server for DSCP, for DNS. You can run these services, DNS service on your router as well. Cisco routers support DNS service, DSCP service, even HTTP service. You can run the application. Just give me 1 minute, please. 1 minute, please. Yes, sir. Understood. Similarly, here we can add the FTP protocol as well. FTP server or TFTP server. FTP, and you can configure the FTP service here. Let me open the file and let's go through it once. Read about application layer, everyone. Read it once. Read it once, everyone. Read. Same thing, right? Port number. What is port number? Any idea about port number?
Every service would have a different port number.
So what is the port number of EIGRP? What is the port number of OSPF? What is the port number of R protocol? What is the port number of ICMP? No, right? These protocol don't have any port number. Correct? So
Correct,
which
sir.
protocol has port number? Which protocol?
HTTP, HTTPS, SSH, Telnet.
Port number works at which layer?
Layer 4.
TCP and UDP.
So all the protocol up to layer 4. All the protocol up to layer 4 will be using port number for their identity. Right? Port number is used to identify the service. For an example, here is one server, and you know on this server we are running DHCP service, we are running DNS service as well, we are running HTTP service as well, we are running HTTPS service as well, and it is receiving one, their IP address is let's say 10.10. It is receiving one packet where source IP is anything, let's say 10.5, and destination IP is 10.10. Destination IP is 10.10. So when this machine is going to receive this data, this traffic, it will check destination IP, destination. With the help of destination IP, it can identify that someone has sent something to me. At which layer? At network layer. But on this particular server, not only single service is running, multiple services running. So the data is for which service? It is DHCP data, DNS data, HTTP data, HTTP. Which type of data it is? For which protocol it is? How you will identify? With the help of port number. Port number is the unique identity of your all protocol up to layer 4, means layer 4 protocol and layer 7 protocols. Whatever protocols we have at layer 7 will be using one port number, and who will use at that port number with data? Your transport layer. Even at transport layer, TCP and UDP protocol is running. Do I have any port number for TCP protocol? No. UDP? No. So
No.
even you can say port number is the unique identity of application layer protocol. Which layer protocol? Application layer protocol means layer 7. Right? But port number will be added at transport layer. So after checking the IP address, your server is going to check port number. If the destination port number is let's say 443, it will hand over this data to HTTPS protocol. If port number is let's say 53, it will hand over data to DNS. If port number is let's say 67, it will hand over the data to DHCP protocol.
DHCP.
If the destination port is 80, it will hand over the data to
HTTP.
protocol. Right? So any device is going to identify service with the help of port number
Port.
at transport layer. And there are two types of port number. Well known and unknown. What is the meaning of well known? See, when we are sending any data, two types of port number is required: source port and
Destination port.
destination port. When I am sending let's say any data to Google, Is source fix? Is
No.
destination fix?
Yes.
And
Yes.
server is, right? Source can be my browser, it can be my laptop, it can be your laptop, it can be mobile phone, doesn't matter what is the source. So source port number will be unknown port number. There are two types of port number, well known and unknown. Well known port number are those port number which we are already assigned to protocols, which we have already assigned to protocol. And unknown port numbers are those port number which are free. We can use it. There are two types of port number, well known and unknown. Well known port number are those port number which we have already assigned to protocol. As a network engineer, you need to remember some protocol with their port number, like well known port number HTTP 80, HTTPS
443.
DNS 53,
50.
DHCP
53.
67 and
67.
48.
BGP
Don't know.
79.
79,
179.
181.
179.
179.
Hmm.
Right, so these are the well-known port number because we have already assigned these protocols to protocol. We cannot reuse it, and there are some free port number which we can use as a source. What is the range of well-known and unknown? Let me tell you that as well. See, port number is 16 bits decimal value. You learn the IP before addressing. Now you can understand any number. It is 16 bits decimal number. So range will be what? 0 to 2 power 16.
16.
2 power 16 is into 65535. 35 or 36? 36. In the range, it will be 5. 0 to 65535. If I will talk about the well-known port number, so port number from 0 to 1023 are well-known, are reserved. We cannot use it. Are already assigned to protocol. And rest port number 203. This is 3. Rest port number 10242 65535 are free. Are free. Clear? So if there is, I have one PC whose IP address is 10.1.1.1, and here is one server whose IP address is 10.1.1.10. Let's say HTTP S protocol is running here. Connected like this. So if I am going to type www.google.com in the browser, what will happen? It will generate one HTTP as request message. Then it will send to transport layer. Transport layer will add port number. Source port number will be any random port number. Destination port will be what? 443. Then we called it segment. What we call this actual request data. Then it will hand over to lower layer, to network layer. Network layer will add IP address, source IP 10.1.1.1, destination IP 10.1.1.10. Then we called it packet. After that, it will hand over to lower layer, data link layer. Data link layer will add source MAC, destination MAC. Let's say MAC address is A here, MAC address is B here. So source MAC will be A, destination MAC will be B, and then we call it frame. And then it will hand over to physical layer that will convert your data into bits, then maybe into signal, then it will send to server. Right? When server will receive the data, it will receive again bits. It will convert into frame. In the frame, source MAC is A, destination MAC is B, and plus packet is there, right? Packet plus this header at layer 2. So here at layer 2 is going to check destination MAC address. Is it my MAC address? Yes, this is my MAC address, correct? It will accept. Then there is one packet. How it will understand this packet? Where I need to send this packet? Actually, data link layer need to verify the destination MAC. If the packet is for server, then it need to hand over this packet to upper layer, to network layer. But at network layer, so many protocols are running. At network layer, IPv4 protocol is also running, IPv6 protocol is also running, EIGRP is also running, OSPF is also running, ICMP is also running. Right? To which protocol it will hand over the packet? IPv4 protocol. So that information will be also there here. That is called type code. There will be type code of IPv4. So it will check the type code and it will hand over the packet to network layer. Network layer will open the packet. Inside the packet, see, two things are there: segment plus IP header, right? 10.1 destination IP 10.10. Correct, guys? Now, network layer is again responsible to check the destination IP, verify it, this packet is for me or not. If it is for me, then again in the IP header there will be one more information, one more field will be there called protocol field. In the protocol field there will be information about upper layer protocol, like at transport layer TCP or UDP, which protocol is working. In my case TCP is working, so there will be protocol number of TCP. Protocol number is different, right? After port number you need to learn the protocol number. Protocol number works at layer 3, port number works at layer 4. Protocol number is used to identify the application, transport layer service, and port number is used to identify the application layer service, right? So if the destination IP address is matching, it will hand over the segment to TCP protocol at transport layer. TCP protocol will open, it will check the destination port number. Destination port number is 443. It will directly hand over data to HTTPS protocol. This is how it will work. So hope port number is clear. Range. And here are some important protocols with their port number and their services. See, this is what you need to learn about the application layer protocol. For an example, telnet. What we need to learn about telnet, Praphul? You need to learn what is the function of telnet. Telnet is used to access networking devices remotely. That is fine. This is the function. Second thing which you need to learn about telnet protocol is what port number it is using. And the third thing is what service, TCP or UDP. At transport layer, which protocol it uses. SSH, again, what is the function, what is the port number, and which service. HTTP, what is the function, what is the port number, and what service. DNS, what is the port number, what is the function, and what is the transport layer service. Getting my point? For every application layer protocol, you need to learn three things. Then here is the transport layer description. You can again read it. This layer provides reliable or unreliable delivery. If there is acknowledgement, we can say reliable. If there is no acknowledgement, we can say it is unreliable. TCP is a reliable protocol. UDP is an unreliable protocol. I am going a bit fast here because these are not so important. Perform error connection before check. Two protocols work, TCP and UDP. TCP stands for transmission control protocol, UDP stands for user datagram protocol. Here you can see the difference between TCP and UDP. Can anyone explain the difference between connection oriented and connectionless? Because here I am saying TCP is a connection oriented protocol and UDP is a connectionless protocol. What it mean?
So with the connection oriented, there's an acknowledgement. So there's a three-way handshake in that kind of communication. But with the connectionless like UDP, it doesn't have an acknowledgement. So when the message is sent, the receiver doesn't need to acknowledge the sender.
Okay, anything else?
There is a sequence as well in TCP compared to UDP.
No, I am not asking you the difference between TCP and UDP. My question is difference between connection oriented and connectionless. Here is my PC whose MAC address is A. Here is the server whose MAC address is B. IP address is 10.1, IP address is 10.10. HTTP protocol uses which service at transport layer? TCP. TCP is a connection oriented protocol. What it mean? It mean before sending actual HTTP as request message, before sending actual request message, I'm talking about transport layer. When this request message will reach to transport layer, it will put this message on hold and it will send one TCP header. TCP header, and in the TCP header you will see there are some flags, some bits are there. So it will on one bit called SYN bit. Sometimes we are also calling this message is SYN message. We are saying SYN message. SYN message is nothing but the TCP header with SYN bit on. When I am saying acknowledgement message, that is again nothing but the TCP header with acknowledgement bit on. And when I am saying SYN plus ACK, it means TCP header with SYN and ACK both bits on.
On.
Clear, sir? So what is the use of this SYN bit? This SYN bit is used to establish or initiate
Connection.
Right? So your client machine PC is telling to the server that, hey, I want to establish a connection with you just for flow control. The purpose is simple: flow control. Understand the benefit. If there is routers, your SYN message will sense the minimum MTU between source and destination, right? Let's say MTU of this router R1 is 1500 byte and MTU of R2 is 2000 byte. So it will check what is the minimum MTU so that it can control the traffic. It can divide large size of data into a smaller part of data. And what should be the size of data? That is called MSS, maximum segment size. What should be the maximum segment size? See, when transport layer is receiving data from the application layer, it is going to add header, either TCP or UDP. The header length is going to be 20 bytes. Then it will hand over to network layer. Network layer is also going to add 20 bytes header. So total length is going to be 40 bytes extra information with data. So minimum MTU is 1500 byte. If minimum MTU is 1500 between source and destination, then what should be the size of segment? If segment size is 1500 bytes, let's say, then after segment it will add header 20 bytes TCP header and 20 bytes UDP header. It will become what? 1540. Sorry. Yes, 1540, and router 1 can discard it. It cannot forward it. So PC will keep the segment size 1460. How it will calculate that? That is called MSS, maximum segment size. Formula is minimum MTU minus header length. Getting my point? Formula to calculate MSS: minimum MTU minus header length. So what is happening here? Your PC client machine will put the actual message on hold and it will send one TCP SYN message. In the TCP SYN message, all the TCP information will be there. All the network layer information will be there. All the data link layer information will be there. Means there will be TCP header In the TCP header, SYN bit will be on, and then source port number will be random port number 1025, destination port number will be 443. Then network layer will be adding the IP header, source IP will be 10.1, destination IP will be 10.10. Then data link layer will add source MAC, destination MAC. It is like this, and then it will send to server. One server will receive, first it will receive at layer 2, then layer 3, then it will check layer 4 information port number. Destination port number is 443, and your server will check is 443 port number open here or not. If it is open, then it will initiate the connection. If this port number is not open, then simply your server will send one TCP header with reset bit on. There is one more bit called reset bit. Reset bit means this particular service is not enabled. If you are getting reset message from the server, that means your port number is not working properly. Okay, but I am assuming that port number is enabled, so your server will send their own SYN message that yes brother, I am also interested to initiate connection with you, and then it will give the acknowledgement of client SYN. Client message, then server message. Client is sending SYN, server is sending SYN plus ACK, and then finally client will send ACK acknowledgement. And now we will have TCP connection here. Now we will have TCP connection here. Can anyone tell me which port number is by default enabled on router? Is there any port number enabled by default on router? By default, one port number is enabled, which is
Telnet 23.
23, and you can enable any port number 53, 65, sorry 67, 68. No bro, I don't want to update. I love older version. Client, and I'm assuming server. This is client, and this one is, I'm assuming, server. and 10.1 and 10.1.10. Like we configure IP address on router in packet tracer, similarly we'll configure IP over here as well. And before configuring the IP, want to show you something. Let me replace this router first. So config t interface f0/0 no shutdown and IP address 10.1.1 255.255.255.0 exit server config t interface f0/0 no shut and IP address 10.1.10 255.255.255.0. If you want to check the open port number, run command show control plane host open port. It is listening on port number
23.
There is one command to check the TCP connection. When I am saying connection oriented, that means I am talking about TCP connection. And here is one command to check that. See. Is there any connection? No. But when client is going to generate the traffic, and see guys, good thing, in the GNS3 you can capture the link to see the traffic over here. I can see all the traffic passing between router 1 and router 2 by capturing the link. Here is my data, you can see on the link. By default some data are traveling between the routers. Right, if I am going to say from the client, if I am going to say telnet and 10.1.1.10, so it is trying to access, and here you can see the messages. Are you able to see SYN message, SYN plus ACK message and ACK message? Before sending the telnet message, here is your telnet, you can see first telnet message, here it is. Before sending telnet message, it establishes one TCP connection. Are you able to see now TCP connection between 10.1 and 10.10? State is not established, but there was session, TCP session. If I am going to send traffic on, let's say, different port number, on port number, for an example, '53. What is saying? Connection refused by host. It tried to establish a connection on port number 53, but server has sent the reset message. Are you able to see?
Yes.
Client machine tried to establish TCP connection on port number 53, but server sent reset message because port number 53 is not running there, right? Similarly, I can send on 443. Again, I will get reset message, you can see. And here on the console, I am getting this error message, connection refused by remote host. For telnet, I can configure the password, line VTY 0, and I can say password, let's say Cisco. Now I can access this auto through telnet. Password Cisco. Now you can see I got the access. And now on the server, if you will check TCP connection, so TCP brief, you can see state is
established.
Now there is a TCP connection between your client machine and server that is established. Now all the telnet communication will happen through this connection, control connection only, right? What is the function of this control connection? To control the flow, right? There are so many things which you need to learn here now. You have to read book for that, sequencing. retransmission, rearranging. So is this point clear? Connection oriented and connectionless.
Yes.
TCP is going to establish connection. UDP is going to send data directly without any connection. We can arrange the receiving data in sequence, but we cannot rearrange the receiving data in sequence in case of UDP. Why? Why? Because there is no TCP connection.
There is no
No
sequence.
sequencing, yes.
Yes. Sequencing.
No sequencing, no acknowledgement, nothing. So how sender machine will get to know that this segment is not received by receiver machine, or this segment is received? Don't know. Sender machine don't know anything about receiver device. Here, if we have the control connection, TCP connection, even your client machine knows the size of buffer memory of your server. Flow control, right? It is going to negotiate their buffer memory as well. That server is going to say, hey client, if you are trying to establish the connection, on port number 23, that means you are going to send me the telnet traffic. This is my buffer memory. I can store this amount of data in my buffer memory. So you can send data equivalent to my buffer memory. After that, I will give you the acknowledgement. If I will miss any sequence in that, then I will request you to retransmit that data. This is called flow control. Retransmission. That's why we are saying TCP is reliable protocol, UDP is unreliable, right? Flow control can be achieved in TCP, flow control cannot be achieved in case of UDP. Windowing. That is windowing, by the way, only. See what happened here, guys. In this case, let's say if client has 1000 segments, client has 1000 segments sending to server. If server is going to give acknowledgement after each and every segment, then communication will be very slow, right?
Yes.
After each and every segment, if receiver will or server will send the acknowledgement, then communication can be very slow. So
will it be less than 60 millisecond?
Doesn't matter whatever time it will take.
Okay.
Right?
So even if it
but
is
sending 1000 acknowledgement message and sending 100 acknowledgement message, there will be some difference in time. Okay, sending 1000 acknowledgement and sending 100 acknowledgement, there will be some gap, correct? I'm talking about that gap. We come up with a technique called windowing to reduce the number of acknowledgement. How? With the help of window size. What is window size? Buffer memory. Same thing, buffer memory. While three-way handshake, both the devices are going to negotiate their buffer memory, and buffer memory size is, let's say, 10 MB, so window size will become 10 MB. And if window size is 10 MB, so server machine will send acknowledgement after receiving 10 MB of data. Example, see this diagram. Their buffer memory size is 700 byte. Minimum MTU is 100 byte. Means the segment size can be 100 byte, not more than that. So when it will send the first segment, server is not going to send acknowledgement. Second, no acknowledgement. Third, no acknowledgement. 4, 5, 6, 7. Now I have received the 700 byte of data. Now it will send acknowledgement. So that's why you can see first segment is coming without acknowledgement. Second, till 7 there is no acknowledgement, and after that server is sending acknowledgement. Now it will send again next segment like this. Again after 700 byte of data, it will send acknowledgement. This is called windowing,
Windowing.
which is only possible in case of TCP, not in UDP. Four-way handshake, like we use three-way handshake to establish the connection. Similarly, we have four-way handshake as well to terminate the connection. When we are done with the data transmission, we need to terminate the connection as well, because guys, try to understand, all the servers will have some kind of limitation, that it can maintain limited number of connection at a time based on their process, memory, hardware, software, right?
Yes.
It is not like server can maintain unlimited number of connection at a time, no. So if there is no data transmission, devices is going to break the connection with the help of four-way handshake. TCP is a slow, definitely if there is acknowledgement, it will be slow. It is even establishing the TCP connection before sending actual data. So it is slow, and UDP is fast, right? There is no any difference in between in term of security. Both are unsecure protocol. You cannot say TCP is secure and UDP is unsecure, no. Header length, size of header is going to be 20 bytes in case of TCP, and header length size is going to be 8 bytes in case of UDP. The another benefit of UDP, it is adding less size of header, and TCP is adding large size of header. It can reduce the size of segment. Then these are the protocol which uses TCP. These are the protocol which uses UDP at transport layer. Segmentation can be done for TCP. Segmentation cannot be done for UDP. What is the meaning of segmentation?
Breaking the data.
Breaking.
Breaking large size of data into a smaller part of data, or dividing large size of data into a smaller part of data. Here is the meaning of connection oriented, which we have already seen. This is the diagram for three-way handshake. You can see sender machine is sending SYN, receiver machine is sending SYN ACK, and then sender machine is again sending ACK message. Then there is connection established, and after that actual data transfer begins. Sequencing, you know the meaning of sequencing. It is nothing but giving the number, sequence number to the segment. MTU, maximum transfer unit. Retransmission, see, for an example, a sender machine is sending this data. Hello, how are you? So here is the sequencing. Sequence number 1 is hello, sequence number 2 is how, sequence number 3 is R, and sequence number 4 is you. Let's say receiver machine have only received these 3 segments. So receiver machine will send acknowledgement to the client, to the sender machine, and then sender machine will retransmit this particular segment instead of retransmitting the entire data. In case of UDP, you have to retransmit entire data. If you miss something, I have to speak again, because our video call is UDP based, not the TCP based. Retransmission is not possible. Clear?
Yes.
TCP is reliable, flow control, okay. Windowing, four-way handshake. In four-way handshake, you can see it is going to use 4 bits. FIN bit, not 4, 2 bits only, but 4 messages. FIN bit and ACK bit. First sender machine will send FIN means that now I am done with data transmission. I don't have anything to send you, so I want to finish the connection. Then receiver machine will acknowledge to the client, and then it will send their on FIN bit. Both has initiated the connection. Now both are saying finish. Finish, finish.
Your voice is breaking.
SYN stand for synchronization. Is my voice breaking?
Cannot hear you, sir.
Huh?
Now it's good.
Okay. SYN stand for synchronization, which is used to initiate the connection. FIN stand for finish, which is used to terminate the connection. And then your network layer. This is all about transport layer, which is the height of OSI model. That's why we go very deep in transport layer. Is it clear? Any question?
Can we change the windowing size?
If you can play with the operating system, then you can.
Okay.
Even we can change the operating system as well on the hardware. We can do everything. As a network engineer, I can't do this. That is the part of our application software.
So between two routers, it depends upon the operating system they are working upon.
No, you can control the MTU, na?
Okay.
Maximum transfer unit.
Okay. Okay. Yes. Yes.
On the router, we can set the MTU. Like on the client machine, I can say interface F0/0 and MTU. What MTU want to set? 100,000 byte. 1530 byte or 1500 byte, like this. Now, if I am going to send, let's say, any data ping 10.1.1.10, 10, and I am saying size 2000 byte, can it ping? Can it send the ICMP packet now? Yes, it can. Now, some question. Ping works at which layer? When I am generating, guys, ICMP packet, ping packet, see here in the capturing, here is your ICMP packet. In the ICMP packet, actual data is there, then network layer, data link layer, and physical layer. There is no transport layer. So who will divide the large size of data into a smaller part? Who is dividing?
Transport.
Where is transport? Transport layer is not there. In this, at this time, your network layer will divide large size of data into a smaller size of data. That is called fragmentation. If I am going to say don't fragment my data, let's say ping with this size and don't fragment. Don't fragment bit. This see ping is not working now. Why? Because now router is not allowed to divide large size of data into a smaller part. And the size of data is greater than MTU. So ping will not work. Success rate is 0%. 5 packet was sent. We didn't receive any reply. But if I will remove the down fragment bit, ping is working because router is capable. Even for the UDP packet, who will divide large size of data into a smaller part? Network layer. For all the UTP based traffic, for the network layer traffic, your network layer will divide into a smaller part. That is called fragmentation. See, there is some difference between segmentation and fragmentation. When I am saying segmentation, it means I am talking about dividing large size of data into a smaller part. And when I am saying fragmentation, that is also dividing large size of data into a smaller part. Then what is the difference?
Fragmentation is at the network layer.
Done at segmentation, done at layer 4.
Transport
Yes. And fragmentation
at network layer.
done at network layer, layer 3. That is the difference.
So, but in which cases we ask like to not to fragment, like don't fragment. We ask a router not to fragment it.
Let's say I want to check the minimum MTU between my laptop and Google server. In the production, what will happen? Many times you will be checking these all things between the sites. Right? Between the sites, there will be so many routers. There will be even public network. If you have two sites at different location in different country, you will connect them through public network. And how you will check what MTU service providers are providing? You will be checking like this only, right? First you will ping with, see, I want to check what is the minimum MTU. So I ping with size 200 byte, it's not working. Now I am going to decrease it. I am going to make it 1900. Is ping working? And don't fragment. Is ping working? Not working. I will again reduce the MTU size. I will check with 1500, 1700, 1500, and then I will get okay, minimum MTU is around 1500.
Okay.
Right? These are the troubleshooting commands used to troubleshoot the issues. From here only you can check what port number is enabled or disable on the server. Like, you know, we know one thing about telnet. Many of you are saying telnet is used to access networking devices remotely, right? This is what we know. But telnet is, you know, more important for troubleshooting. We are using telnet for troubleshoot. Let's say I want to check port number 443 is enabled or not on the server. I will telnet 10.1.1.10 and then I will drive the port number 443. If it is saying connection refused by remote host means it is not enabled. Let me enable the HTTPS service on the server. IP HTTP secure server. Done. Enable, and now go to client machine and check port number 4. Now you can see it is open. Port number is open, right? So through telnet we can check this as well, that port number is open or not. Similar, if I will check port number 53, port number 3 is not open, right? If I will open the port number 53, IP DNS server, and now if I am going to test, what happened? Port number 53, how to enable? IP host www.pmnet.com, IP address 10.1.1.10, and so control plane host open port number 53 is enabled.
Yeah. Sorry.
Now go to client machine and check. Similarly for DHCP IP, DHCP pool Cisco, and now so port number, now you can see 67, 68, 67 is enabled. If I am going to run IP DHCP 68 will be also enabled, right? And through telnet we can check it is enable or disable, open or not 67. These are the issue of simulation, right? Showing remote host refused by remote host. Check the IP address is correct, 67 port number is correct, it should be open like this, right? So these are the troubleshooting tools which we are using to troubleshoot telnet. And not only this, there are many more functions of telnet or any other protocols, application layer protocols. There are multiple functions of single protocol. Anything else guys in transport layer? Because today I am not starting network layer. We'll start this in next class. Tell me. So in the GNS3 and packet tracer, make sure you will also practice it, and I will connect you tomorrow. And guys, make sure previous all topics are very clear and crystal to you, because day by day I will be increasing the speed and we will be learning the modern networking. These are the basic but foundation: OSI, IP, networking, broadcast domain, collision domain, right? NICs, function of switch, function of router, routing table, MAC address table, right? These are the only topics which I am expecting from you, that you have good command on these.